So today's lesson is going to focus on another method of doing proofs. But first we need to back up a little bit. In Unit 1, we talked about indirect logic, where we talked about P implies Q, but we implied not Q, not the conclusion, and that guaranteed not the P. And we did it with the diagram that if we eliminate the larger set, the subset is automatically knocked out. Now we're going to use a similar sort of logic to do indirect proofs, plus the general teen cheekiness. We're going to break into two groups. Our answer either is or it isn't. So our A is our original. What the problem's asking us is going to be true. We are going to say, yeah, but it could be this other thing, just to be difficult. And then we're going to try to prove our other thing. And when it fails, then our original must be true. Okay, so it's kind of a backdoor approach to a proof. Since it can't be the other half of the options, then it has to be the original. So these are called indirect proofs. We are going to temporarily assume that what we want to prove is false. By showing this is false, conclusion is impossible, we prove our original is true. So our step 1, identify the conclusion. That's our then or our prove. Okay, whatever our then or our prove is. And then we're going to rewrite this conclusion as false. And I've put quotes around it because sometimes we're thinking about opposite. We're flipping a sign. Instead of equal, we're doing greater than. Instead of parallel, we're doing not parallel. Just something different but related. Step 2, we're going to use our normal proof steps. And what's going to happen in step 3 is we're going to get a contradiction. Something's going to happen that can't happen that's going to show that our original one was actually true. Therefore, because the false assumption can't be true, the original must be true. So if we start with if x equals 2, then 3x minus 5 is not 10. The blue box, so the then part becomes our assume. We are going to assume that 3x minus 5 is equal to 10. Okay, so we picked the opposite situation. Now we're going to do our regular proof steps. And what we realize, we're going to add 5 to both sides. 3x equals 15. Divide by 3, we end up with x equals 5. And this is a contradiction to our original. So therefore, the original must be true. The only way to get it equal to 10 is if it equals 5. So if x equals 2, then it can't equal 10. So we proved it by contradiction, that that original was true. Our next example is going to say if x is greater than 3, then x squared is greater than 9. So our false statement is either x squared equals 9 or x squared less than 9. If you want to be really fancy, you could do x squared less than or equal to 9 and cover both of them. If we show that either one of these is a contradiction, our original is true. So we're going to start with x squared equals 9. We're going to start with that as being true. We're going to pretend for a moment that's what we want. By definition of square root, x equals 3 or x equals negative 3. Oops, that's a contradiction. Equal isn't the same as greater than. Therefore, our original is true. And it's just that simple. Here's our second example. This one really illustrates this point well. If triangle ABC, angle A is 110, then angle C is not a right angle. So my then part turns to a false assumption that C is a right angle, and then I'm going to go through a proof. Now, first step, if I have a triangle, one thing I can always write is that A plus B plus C equals 180 by the triangle sum theorem. All the angles of a triangle are 180. By substitution, I can replace A with 110 from the given. So 110 plus angle B plus angle C is 180. Substitution. I'm going to subtract 110 from both sides to get B plus C equals 70. Now, my false assumption is that C is a right angle, so now I can write that angle C equals 90 by definition of right angle. When I do that substitution, you can see the contradiction begin to emerge. And when I get to the bottom, that B is negative 20, it can't possibly be a negative value. Then I have a contradiction. I can't have a negative B, therefore C cannot be a right angle and must be something else. Just to be safe, I've added another example that's not in your notes. And this one says if negative 3x plus 4 is greater than 16, then x is less than negative 4. So my contradictions, I could choose any one of those three. X equals negative 4, x is greater than negative 4, or fancy, x is greater than or equal to negative 4. Start with my given, negative 3x plus 4 is greater than 16. Subtract 4 from both sides. Now remember, when you divide by an inequality, that sign has to flip. And what I've got down here is if x is supposed to equal negative 4 and it doesn't, I have a contradiction. So the original must be true. And so that is how you do a proof by contradiction or a proof by the indirect method. And good luck with your homework.